Okay, all three. Now, all 5 types of cells. What 5 types of cells? Go back a couple of slides. Anybody got their slides on paper? Print it off. Mateen, you got it? All right, so hold on. Okay, so mast, white blood cells, huh? What? Fat cells, my macrophages, plate. That's not a cell. It's just a, well, I just kind of like magnet, like, it's a, platelets are not considered a full cell. We'll find that out in the blood, okay? But let's see, so 1, 2, 3, 4. The stem cells. Huh. Huh. Why would this fascia, this sheet that we term the subcute or the hypodermal layer, okay, why would it be, first of all, have the kind of loose matrix that's present, and in that matrix, all these cells existing? All right, if we're protecting ourselves from the outside, what would have to be taking place for this to be beneficial? Well, if we think about the fact that the skin is the layer that's between us and our internal part and everything that's out here to the external part, okay? What is something that the skin is trying to help us keep out? Bacteria, viruses, toxins, anything that might try to invade us. How would stuff like that be able to invade us? What? Cut. A breach through this outer layer. Now, when we look at the skin, it's going to seem like skin gets to be really thick, but it's not, okay? But the layers are kind of cool that are going to be present. Then underneath, we're going to have our basement membrane, which is going to have that connection with the connective tissue that has all those cells. Now, a breach to the outer environment could be something as simple as a paper cut. All right? Do you really, like, think long and hard about the paper cut? Why? Okay, small, not like a big wound. Okay, well, I don't know, maybe. All right, I'll use an example from my favorite show. All right, I love Walking Dead. Okay, and I don't know, you're out there having to fight the zombies. Okay, and you're like, I don't know, running through the trees and everything, and you're getting all scratched up and bummed up and whatever, okay? Now, big versus small. Is there a huge difference? A little bit. Could be some damage to the muscle, if we got that far. But the goal, anything that's going to try to invade from that outer environment to the inner environment, what do we see it immediately encounter once we get through the layers of the skin? I'm seeing it encounter mast cells, macrophages, white blood cells. Then my blood that's there is going to be able, because you get a paper cut and you bleed, right? You kind of look at it and go, okay, that's done. And just keep on going with your day, right? Okay? Takes what? Less than a minute for it to probably stop, as long as you're healthy and everything's working correctly. All right? A little bit deeper cuts, okay, gotta pay a little more attention, blah, blah, blah. But they're gonna have the ability in the blood to rush cells to that area to help those cells.
I have a question actually. Okay, so, or see, whatever it is. I was writing on that one point where I was trying to take a shower and I wanted to close the window, and I guess I was being stupid, but I stepped onto the soap rack where next thing I noticed it broke and it sliced my hand, like this part right here. So I remember as I was bleeding like no joke, but I saw some white stuff like inside my, like I guess it was really deep. So I saw some white stuff.
Now, was that as you were bleeding, or did that come along
like,
later?
I think it was towards later, like they were cleaning
later.
it up, yeah.
That's when you're gonna, actually what happens, it's really cool. The white blood cells that are gonna rush to that area to help fight anything that's trying to invade you, they're gonna die off. And they'll actually have to seep out in some way. So depending on the amount that has to get there, okay, and then whatever bacteria they encounter, it's just simply the cleansing of the wound. Yeah.
Because that was actually one thing that really fascinating. It was fascinating.
Mm-hmm.
Painful, but fascinating.
Yeah. So it's really cool, you know, what happens. I'm pointing this out because of how important this is to anything that breaches our, you know, internal versus external environment. And it's encountering all of those cells, which I think is amazing. Okay? We see that this loose connective tissue. Now note that in talking about it being loose, we can see that they're trying to point out collagen fibers. Collagen fibers are going to be the ones that are very thick fibers, because if that's what's giving structure, we do not want those fibers teeny tiny. Okay, so collagen is technically, it's a huge protein fiber. And then they're pointing out these little ones that look like the strings going through here. That'll be the elastic. And then the ones that are sort of intermediate that they're not really pointing out, those are going to be the reticular. But the majority of what you're going to find in this loose connective tissue under the skin, we're going to find a lot of the collagen because it's helping to give structure. Okay? How do they sort of tout collagen to us as a beauty product? Okay? They'll be, okay, like I was talking about, you know, they go get the lips injected and visually just, you know. But then, wait a minute, does it stay that way? So what does that tell us about injecting that collagen into the body? It's not permanent, and the body's going to destroy it. Okay? So they think it's like a permanent solution, but it's not, because when we look at what happens, collagen fibers, when they break down, they don't come back. Okay? Which is the reason we begin to see the fine lines, which are little wrinkles and stuff like this, the little dimples in the skin, that sort of thing. The elastic fibers that we find in this connective tissue, they get stretched beyond a point where they cannot recoil, okay? what's going to happen? We end up with stretch marks. Okay? So these fibers give a lot of support to the structure of the skin. All of our cells, like I was saying, all of these cells, and it looks like everything is in Jell-O. So it is a very loose setup, a loose structure for that tissue. Now, some of this connective tissue that looks very loose, okay? We've got adipose tissue. Adipose tissue, also known as the fat, okay? The cell, it looks like the majority of what you find in the adipose tissue is cell against cell against cell against cell. So at this point, even though we're looking at a matrix that is loose, okay, the cells are closer together now, all right? So in this fat tissue that we're going to find, okay, it's cells closer together and the extracellular material is not as much, okay? And then it also looks like those adipose cells are empty. It looks like it's a huge space, all right? But it's not. It's actually the fat. And then the nucleus, can you kind of see the little dots that are showing up? The nucleus of the adipose cell gets pushed to one side because it's full of the fat tissue, of the fat material, all right? Now, when we look at fat sources within the body, okay, yellow or white, okay, is going to be the most abundant. This one, basically when we're born, at birth is white, but as we age, begins to take on a yellow appearance. So think about like what we're talking about in, say, for the middle of bones, okay? Now, when we look at one of the things that's important that this tissue can do, what's keratins? Any idea what a keratin might be? It's a pigment, okay? It's a plant pigment. What do we mean by pigment? Are all plants just simply green? No. We find them in a wide variety of colors, right? So pigments are letting us know the colors. Keratins, you've probably heard about this in relationship to like carrots, for example, squash, okay? Foods that are going to have these yellow-orange appearance, okay? Because that's what the keratins are. And when we're taking in these particular plant substances, one of the things that becomes important is to have them available so that we can make vitamin A. Like when I was growing up, they used to tell us, you know, of course, as older I am, we didn't know as much back then as we do now, okay? But one of the things that I was told growing up, eat your carrots, because the carrots were good for my eyes, okay? Well, now they're finding, like, for example, blueberries are good for your eyes, okay? Because of the nutrients that they contain. Maybe that's what's wrong with mine. No, mine's just age. It's just what happens when you get old. So, in this fat tissue, we can metabolize and get the vitamin A, which is very important in our diets. Now, like I was saying, the plasma membrane, the nucleus and all the little organelles, because of the fat that gets stored in there, it kind of pushes all of that material to the side. And that's why you'll see the nucleus just lying off to the side in the pictures. The brown fat, we only find this in certain areas of the body. What's the axilla?
Armpit.
Armpit. Do you know that's why you're attracted to your mates? When you find the person that when you see them and you go, oh, okay, you're actually attracted to their armpits. Just say. Now, the neck.
They also have studied that when women smell the armpits of men, they have a normalized menstrual cycle.
So that they can be reproductive on the days that they're supposed to have the fertilization of the egg. Cool. Propagation of the species, all right? Which, hey, that's the goal of every species out there, if you think about it. And then, near the kidneys. Now, the reason that it's termed brown, it has a huge blood supply, okay? And one of the things that the brown fat is good for is supplying heat, okay? Helping with retaining heat. Yes, for the brown fat in babies too, right? This is actually considered the special loose connective tissue. Now, reticular, you've heard me mention quite a few times, mainly because when we get to talking in part 2 about our endocrine system and our lymphatic system, the reticular tissue is going to become very important, and it's due to the structure. Because reticular tissue is so web-like, okay, there's like no structure to it whatsoever, and the way that it does all of this webbing and looks like tree branches just hanging out, it can trap cells. And that's going to become important to us in areas where we find it. For example, the spleen. What do you normally think about happening when you hear about your spleen?
Rupture.
Okay, and when it ruptures, what can happen to the person? Why can they die? What happens? Because what's a whole lot of being in the spleen? What do we have a whole lot of in the spleen? Blood. Because one of the things that the spleen can do, it can help with the lymphatic system, but one of the biggest jobs that the spleen does, destroy the used up red blood cells. And that's why it's usually termed a blood organ. And if it ruptures, person usually hemorrhages, and if they don't get the surgery in time and get all of the blood out of the belly, they're going to die.